Welcome to the Developer Service YouTube channel. On today's episode, we're going to be talking about object-oriented programming in Python. Of course, we were talking about classes and objects. You can follow along with the blog post on Developer Service blog. Let's get into it and see how do you program with object-oriented in Python. So before you start, just a couple of definitions. So what is object-oriented programming? So object-oriented programming organizes software around data and objects. And an object is like a container that has attributes, that is the data, and has certain behaviors, which is the functions. There's several concepts related to the object-oriented programming. There's encapsulation, which means bundling the data into one single unit, data and the functions. There's the abstraction, which is hiding the complex implementation that is behind that object, for instance. Inheritance, which allows for one class to be derived from a different class. There's polymorphism, which is the ability of having an interface that can represent different data types. That means that we can have a class that can represent different types of class. So we have the concept of parent classes and child classes. So object-oriented programming in Python, we have classes and we have objects. So a class is like a blueprint for creating objects. Let's see that in action in the code. So we define that in Python with the class car. So you're defining a class called car. We have the initialization method, a constructor like you would call in other languages, which takes care of initializing the object when the object is created. And we have a method here, start engine, which is the function that performs some action. And of course, we have the data, which is handled by the variables and use self inside a class to access the class attributes. This is a class definition with initialization and with the function. And then we have the concept of object, and object is an instance of a class. So in this case, we're going to create a car or a my car. We're going to be saying that it's an instance of the class car. We're going to be passing the make, and as you can see, that corresponds there to the parameters of the initialization. And to pass the make, we're going to be passing the model, and we're going to be passing the year. And that will instantiate an object of the class car. And since this object my car is from class car, we can start the engine, meaning we can call that function of that class, and it will provide the output as the function is executed. And if we run the code, you see that the Corol's engine has started. So that's the concept of a class and the concept of an object. So let's now take a look at the concept of inheritance. So inheritance is one class takes on the attributes and methods of another class. So the child class takes on attributes and methods of the parent class. So let's see that as an example. So here we have a class vehicle, which has a make and a model and has a function, drive. Then we have a class car, which is a subclass of vehicle. So it will inherit all these properties of the class vehicle. As we can see in the initialization of the car, we're initializing super, which means we're initializing the parent class. And while the vehicle class, so the parent class had a make and a model, the car adds another internal data to the class car itself, so to the child class, and it also implements or defines the start engine method. So as you can see, instantiating these objects, we have the my car, which again, we're instantiating to be a car. So we're passing the model, the make, the model, and the year, and that will instantiate the class. We can call the drive because we are inheriting that from the parent class, and we can also call start engine, which is the function inside the car class itself. So the inheritance allows to define a parent class with certain data and certain methods. It allows for a child class to inherit it from it and can add its own data and it can add its own methods, but it also has access to the parent methods of the parent class. So next we have method overriding, which means that sometimes the child class might need to change or add behavior to a method that inherits from the parent class. That is done through method overriding. So let's see an example. Here we have a class vehicle that has a method drive, and we are defining the class car, which is a child class of vehicle, so it inherits from vehicle. And here we are overriding the method drive. So when we instantiate a vehicle and when we do a drive, it will be printing driving a vehicle. But when you instantiate a method, an object from the car class, and we do the drive, it will say in driving a car because that method has been overridden. As you can see, driving a vehicle, driving a car. So method overriding allows the child class to override a method from the parent class. It allows to keep the same interface or the same definition of the methods, but it allows for specific behavior in that class. In this case, a car obviously has a particular behavior in terms of driving than a general vehicle. Next up, we have the concept of multiple inheritance, which means inheritance from more than one parent class. Let's see that as an example. So here we have the class vehicle that has a method drive. We have the class electric, which has a method charge. So of course, we can then create a car that can inherit from vehicle, which is a standard car. And so it has a start engine, as we saw in the previous examples. And then we have a hybrid car that can inherit from car itself. So it will inherit all the properties of being a car, all the properties of being a vehicle, but can also inherit from the electric class. So it will also have the properties of the electric class. So that means that hybrid car, when we instantiate an object from the hybrid car, that means that the hybrid car can start the engine, which is defined from the car, can drive, which is defined from the vehicle class, can charge, which is defined from the electric class, and can switch mode, which is defined inside its own hybrid class. So multiple inheritance allows to inherit principles from one main class and from another main class or parent class. It can go through one intermediate other class, and then we can have a final class that is inheriting, or child class that is inheriting from two other parent classes. So that allows to aggregate a whole combination of data, of course, but also different combination of the methods. So the polymorphism, it allows to perform different action based on the object that it's being worked on. Let's see that in with an example. So we can do that with a function. So here we have created a class dog that has the method speak, class cat that also has the method speak. Of course, they speak in different ways. So either woof for the dog or meow for the cat. We can define a general function not related to any of the classes, and we can define that general function. In this case, we call it make a speak, but you'll receive an object that's called animal, or it will be in the animal variable, and then we call that speak. So when we instantiate a dog object and a cat object, we can pass those objects to the function, and that will call the proper speak inside that object. We could also have replaced it here and could have been dog speak and cat speak, but we can make it a bit generic. So we have this function that takes care of calling the speak because the methods are using the same method name. And so that's how you can achieve the polymorphism, which means that one single function has different behaviors depending on the object it receives, in this case the cat or the dog. And if we see the example, woof and meow. You can also define polymorphism with class methods, and that means also the class hierarchy, like we saw before, the parent and child class. So we can define a base class that will be a parent class that is called animal, and the animal of course can speak. In this case, the animal does not know how to speak because speaking is different for a dog or a cat. So in the base class animal, this method is not implemented, and the subclass must implement this method. So when we implement the dog class, which inherits from animal, we need to implement the method speak, and we implement it by returning woof. And when we implement the cat class, which inherits from animal object, we implement the speak class again, and that returns meow. And so we can create a list of animals here, which is an instance of a dog, an instance of a cat. For each of the animals, we call speak, because it's kind of a more dynamic way in regards to what we saw before. And it will, of course, call the specific method and of each object, and it either be woof or meow. So then, as we mentioned before, we have the concept of encapsulation or data hiding. So that is combining data and methods that work inside one single unit, normally the class. That's involve restricting access to certain parts of that class or the instance of that object, and only the public attributes are accessible. Private attributes is not. By convention in Python, you can indicate that attribute is private by prefixing it with an underscore. It does not actually prevent the access from outside the class, but it's a convention that tells other programmers that you should not be using that particular method. Let's see the example. So here we define a class account. We have our initialization method, and you see we have prefixed one of the data elements with underscore. So the underscore balance should be treated as a private attribute, and so it should not be handled directly outside of the class. So that means that we need to have some method that allows to interact with this balance. So that's why we can create a method called deposit that receives an amount, and obviously deposit increments that balance. We can have a method called redraw, which receives an amount. Of course, if we have enough in our balance, we can redraw that amount. Of course, if we not, then we have insufficient funds. And we can also have a method called getBalance, and that does not receive any amount, of course, but that returns the current balance. So you can create an account with a particular balance in the name, so that my account object, we deposit an extra 500, and then we can call the getBalance and see what is the output, 1500. So that's how we can define a private data, and we can control the access through methods. So now we're going to be discussing a bit more of advanced object-oriented programming concepts. We have the concept of class methods. Those are methods that are connected to the class, not an individual instance of that class, and that affects the class itself, which in turn affects all the instances of that class. Let's see an example. So here we have a class that we call car. We have defined an internal variable called total cars. We are initializing and this variable is available to all the instances of the class. So this is a class attribute, and we have the initialization, and we see every time that we create an instance of the class, we're incrementing the total amount of cars, and then we also defining a class method that can access this class variable, which gets the total cars, which returns the class, which receives the class, which is automatically handled by Python, and that we can returns the total of the cars. So let's quickly go through an example. So here we're creating 3 different cars. So each of these cars will affect the class data total cars, and we can get it with the class method and get total cars. So as you can see, car 1, car 2 are the object instances, but when we're getting the total cars and calling that method, since it's the class method, we're accessing it through the class itself and not an individual instance of the class. We'll see the output, and the output is going to be G because we added 3 cars or 3 instances of the object, 3 object instances of the class car. So we also have the reverse of the class methods, which is the static methods, which is methods that belong to the class, but they do not affect any of the instances of the class or the state of the class itself. Let's see an example. Here we have a class mat operations, which has a static method, which is called add, but as you can see, it performs an operation on the values that it receives, but it does not affect any of the instances of the class. So let's see how we can call a static method. It's the same way as we call a class method, because it belongs to the class itself. So we have the mat operations. We call the static method add, pass the parameters. It returns the value, and we're going to print that value. The value is 5. So the static method allows for a class to define methods, but it does not affect any of the instances or the instances of the class or the class itself. And finally, we have the property decorators, which defines a way to define getters, setters, and deletes for a class attribute, like we saw before in the private and public class attributes, but in a more Pythonic way. Let's see that example. So here we have a class employee, which has private methods, the name and salary. We create a property that is called salary, which allows to, by default, it's a get method, so that returns the value of salary. We can also define the salary property, which inherits from the previous one, and we can also define that it has a setter. So instead of being just a getter, which is normally defined by the property in the salary, in this case we define that that property can also have a setter, which you also define a salary, and that of course if the value is not 0, then the salary cannot be negative, and if it's positive, then we set the salary to that value. So let's see a quick example of how the setter and getter methods work. So we create an instance of that class, emp, for the class employee. We pass the name John, we pass an initial salary, which when we print by the getter method, which is going to be this one, it returns the salary. So it will return the 50,000. We can use the setter method, which is also called salary, to provide a new salary. And when we print, it's again the getter method, and it's going to print out the new salary. If you see that in execution, the 500 and the 600. That's how you can define getters and setters for a private data element of a class. Thank you for watching. Like this video if you like this content. Subscribe to the channel for more content about Python, Django, and AI. And also, some news. I've created also courses for Python and in the future for more other technologies. You can access it at the coursesdeveloperservers.blog. There will be a link in the description. At the moment, I have a generic programming course, which is about simplifying the concepts for beginner developers. So it's no code at all, but just explaining the basic concepts about programming. And I also have the course Python for beginners, which deals with programming in Python and explains how to program in Python through different set of chapters. The concepts course, that is a free course, and Python for beginners, that is a paid course, but it also has 3 free chapters that you can take a look and see if the course matches you. It's a completely text-based course with hands-on exercises and with very detailed explanations. So please do take a look. And if you decide to buy the course, which is already on discount, but if you decide to buy the course and you use the coupon code courses25, you get an extra 25% discount. So until next time, happy coding!